Good day to all. This is Remya Rose, Assistant Professor from Department of Artificial Intelligence and Machine Learning from RMD Engineering College. This video we are going to see about the Hadoop distributed file system. So we all know Hadoop is going to be a framework which helps us do our computation on a larger data set. Mainly Hadoop framework works for a larger data set. So the Hadoop framework could be broadly classified into two. One is the storage portion and the other one is going to be the computation part. So the storage portion is called as the Hadoop distributed file system, and the computation we call it as MapReduce. So about MapReduce we'll see in some other video. For this video we'll see about the storage of Hadoop distributed file system, or let's see how a file is stored in the Hadoop storage. We know what is a file. So any collection of data or interrelated data item, we call it as a file, and the file could be managed in a single location or in a distributed environment. Here for Hadoop is concerned, we always know Hadoop storage is going to be distributed and its processing is going to be a parallel processing one. So now when you want to talk about the storage of Hadoop, in Hadoop, the files are stored in a way that when you get a larger data set, the whole larger data set is not going to be stored in one particular location or one particular node. The data set or block of information is going to be broken down into chunks. So each block could be of 128 MB by default. So the Hdfs break the particular data set into smaller chunks, and these independent unit or the chunks could be loaded in different nodes. So when we talk about nodes of one Hadoop cluster, for every Hadoop cluster there will be only one name node, and you can have n number of data node. So based on the data set, based on the computation we are going to do, we can scale the number of nodes we want to have. So the name node and data node work in a way of master slave pattern, where your name node will be the master and all the data nodes could be the server who is going to serve for that particular master. So now the name node will be something like an index page. It will be holding all the metadata of that particular file. So say for example, you have a larger data set. The larger data set is broken into chunks, and each chunk is going to be loaded in different nodes, and the copy of the chunk is going to be replicated in the elsewhere of the nodes too. Now the information about the file as well as the information about the replica of the file is going to be put in the name node, and the data node will have the original information itself. So let's see the diagrammatic representation. This is actually the diagrammatic representation of Hdfs, where this is the only one name node, which you call it as the master. We have three data node for this example. So now if you could see, we have the metadata or the information about the file in name node, whereas you can see in data node you have the independent unit called as chunks of data. So the original data set or the information is being broken down. For this example I'm telling, is broken down into 5 pieces, it seems. So block 1, block 2, block 4 and block 5 are placed in data node 1. And you can see block 1 is replicated in node 3, block 2 is replicated in node 2, block 4 is replicated again in node 3, and block 5 is replicated in node 2. And if you can see that node 3 is missing over here, block 3 is missing over here. So block 3 is placed in node 2 and also replicated in node 3. So it is, it is of your choice, to load the information or the independent information in data node. So we have a replication strategy that we'll see in some other video, like how the replication is done. But for as of now, just keep in mind that your Hadoop distributed file system, from the name you can understand, a file system which is going to be distributed in the sense your file is going to be broken into pieces, and the pieces could be located in different nodes. So now we have one name node and three data node. Data node will have the data, whereas the name node will have the metadata of that particular file. So the information is broken into chunks, and the pieces of chunks are put in data node and it is replicated elsewhere. This is actually the architecture or the structure of a Hadoop distributed file system. Now we'll see how a read operation as well as a write operation is performed with Hadoop environment. So now we know read is always done in a file which is already existing, whereas write is done to a fresh file. You're creating a file and you're going to perform a write operation. So now in a Hadoop distributed environment, if suppose an application wants to read a file which is already available in some data node, what happens is the client first raises an open request to the distributed file system. So based on the open request, the Hadoop distributed file system communicate to the name node, where the name node is actually the one which is going to hold all the metadata about the particular file. So from the metadata, the location of that particular file could be obtained. So once I know the location, the read request is raised through the file system data input stream, and from that particular location, the file is read. When the end of file is reached, the file will be closed. So now we start from open, we end in close. Meanwhile, we have 2 or 3 steps done. So the client raises an open request to the distributed file system, and the distributed file system communicate to the name node to get the location of the file. Once the file location is obtained, the read request is raised through the file system data input stream to the proper location. The read is done, and when the end of file is read, the file could be closed. This is how from the Hadoop distributed file system the read operation is done. Similarly, we'll see how a write operation is done with respect to Hadoop environment. So earlier itself I told you read operation could be done to a file which is already existing, whereas write operation is done to a file which you are creating new, or sometimes from to an already existing file you may try to append information. So now here in this example, I'm going to write a fresh file. So now when my processing is done, or when I want to write an output or whatever it is, the client raises a create request to the distributed file system. Since it is going to be a create, the Hadoop distributed file system is going to get connected to the name node, where it is not going to seek for any location, but it is trying to seek for any available space, where in that available space I'm going to create my new file. So now when my location is set to that particular location, the write operation, write request is raised through FS data output stream. In that particular data node, my write is done. Write packet by packet, my write operation is done. So now when my write is complete, the data node will send an acknowledgement packet. So when the acknowledgement packet is received by the distributed file system, it comes to a conclusion the write operation is done and the file will be closed. So one small difference between the write as well as read is read will raise a open request, whereas write will raise a create request. So once I get an open request, the Hadoop distributed file system communicate to the name node to get the location in read, whereas it is trying to identify the free space and find a location to create my new file in my write. So now when my location is got both in read and write, next will be read operation will be executed. Here the write will be executed. When end of file is read, you close the file in read. Whereas after the complete write is done, the acknowledgement is sent back to the distributed file system and the file will be closed. This is how the read and write operation are performed in Hadoop distributed file system. Thank you.